Let's read the rubric together. Copper 2 carbonate with the formula CuCO3 can undergo thermal decomposition to form copper 2 oxide with the formula CuO and a gas. So what's the key information we've been given here? We have started the reactant is copper carbonate. The chemical reaction is thermal decomposition, and what we've made is copper 2 oxide and a gas. Let's look at part A together. Write a word equation for this reaction. Write is the command word. And remember, this needs to be a word equation, so we don't want the formulas, we just want the names of the chemicals. So when we write the word equation, we start with the reactants, a goes to arrow, and end with the products. Looking at the rubric, we can see that the reactant is copper 2 carbonate. Now the 2 is important because it tells me that the copper makes a 2+ ion. And what have I made? I've made copper oxide and a gas. Now a gas, it could be any gas, so let's try and work out what the gas is. Copper carbonate has the formula CuCO3. It becomes copper oxide. What's left over? 1 carbon atom and 2 oxygen atoms. That could be the gas carbon dioxide, and indeed that's the other gas that is made in this reaction. Looking at part B, calculate the relative formula mass of copper 2 oxide CuO. The relative atomic masses of copper and oxygen are given to us. So the command word is calculate. And what we need is the relative formula mass of copper oxide. So what we need to do is add the mass from the 1 copper atom to the mass of the 1 oxygen atom in that formula to work out the overall formula mass. As ever with a calculation, you need to show your working. So 63.5 plus 16 equals 79.5. And that there is the relative formula mass. Please notice that the relative formula mass and indeed the relative atomic masses have no units. So the answer is simply 79.5. Looking at part C. Explain why the mass appears to decrease during this reaction in a non-closed container. The command word here is explain. And what we're explaining is the mass appearing, so it doesn't actually, appearing to decrease in a non-closed container. So why does that happen? We must be losing some of the products, the chemicals that we've made from whatever vessel we're doing the reaction in. So copper oxide is a solid. That's still going to be in the container that we're doing. But carbon dioxide is a gas, and we can see that in the question here. So that gas will be lost to the atmosphere because the container is not closed. And in doing so, the mass of that gas is lessened on the balance, and that's why it appears that the mass has actually decreased. So how could we write that as an answer? One product is a gas. That would be 1 mark, and escapes into the air. And that's what causes the mass drop there, and the escapes into the air is the 2nd mark.